Today is about exponents, and we've talked about this a little bit already, but we're going to go into much greater detail as well as do a couple examples. So all an exponent is if you have a base, right, say the base is 4, and you raise it to the exponent of 3, then that's just 4 times 4 times 4, which is 64. Make sure we are recording here. Good. So that's how it does. And when numbers is fairly straightforward, and we get to use calculators, so you can easily just type this into a calculator as well. Always be careful with your calculator, right? Because there is a difference. -2 squared is the same as writing -1 times 2 times 2, which is -4, versus -2 in parentheses squared, which is -2 times -2, which is 4. And the reason I like to talk about this is because if you go to type this in your calculator and you type it just like that, your calculator is going to give you the answer of -4. I can't guarantee what cell phones do. I always tell my students I'd rather you not use your cell phone calculator because I can't guarantee that's going to work properly, but a calculator will work properly. So if you want the negative to be squared, then you must put it in parentheses. If you do not put it in parentheses, it is going to assume that you have a -1 on the outside, and then you're squaring just the 2. All right. So, rules of exponents. If I have the same base, a, and I'm multiplying it by the same base, a, with a different power, even if they're the same powers, if I have the same base and I'm multiplying, I then add the powers. If I have the same base and I am dividing, I then subtract the powers. The book goes into all these, if it's bigger than this, do this, if it's bigger than that, do that. I would not concern myself, just subtract them. Because we have another rule, if my exponent is negative, then I just flip it. And that's why when the book goes in all this details about making sure you subtract the bigger number, it really doesn't matter. Because in the end, if I have a negative power, I just flip it. Anything to the 0 power is 1. All right, put a little dash here so we can put our rules here again. Anything to the first power is itself. So we usually don't write ones because, again, I like to say we're lazy mathematicians. And then if we have a base to an exponent raised to another exponent, that's when I multiply them. So some examples of why you have to be really careful with how it's written. So there are the rules, and you don't have to have them memorized, right? Because the test is open note, and so is the homework, but make sure you write them down so you can reference them quickly, because that's all the rules of exponents. And there is no more rules. The problems just look ugly. They don't get any harder. They just look worse. But these are there's 5 rules, I think. 1, 2, 3, 4, 5, 6, if you include the power of 1, right? So 6 things that you're going to have to follow through with. So some examples that are very similar. If I have 4x squared, and I'm timesing that by x cubed, well, that just equals 4, right? Because it's all by itself in the front. The same base of my x's, so I just add the powers. So that equals 4x to the 5th. If I have 4x squared all over x cubed, then the 4 still stays, and then I have the same base, so then I subtract them, which then gives me 4x to the -1, because 2 minus 3 is -1. The negative tells me I flip it. Now this is where you have to be careful. The negative is only on the x. So I don't flip the 4, I just flip the x, and it becomes 4 over x. And then if I have 4x squared all cubed, now I have to distribute the 3 through, and I don't just distribute it to the to the x, I also distribute it to the 4. So this becomes 4 cubed, and then we multiply the powers, right? So this becomes 2 times 3. That's not a decimal, it's a times. I'll put in parentheses just so I remember it's times. So 4 cubed, we already did that. We said that's 64. And then we multiply the powers, so that becomes x to the 6. So even when our starting point is very close, right? They all have 4s in them. They all have an x squareds and a third exponent. Depending how it's written, I get very different answers. I get 4x to the 5th, or I get 4 over x, or I get 64x to the 6th. Very different answers depending on how it's written. So you just got to be careful when you look at these on how they are written. Any questions on the rules? I'm going to do another example here, but before I put on a more uglier example, I just want to make sure that I have no questions. I don't see anything in chat. So make sure you write these rules down if you want them, because I'm going to have to go to a new page. I can always come back to it if you need to see them again. So if I have, I'm going to try to write decent as best I can here. 5 y squared x cubed times 2xy cubed all over 4y x squared x times y to the negative 2. Right, so that looks pretty bad. But notice, there is no addition or subtraction anywhere in this. So this thing is called a single term. So everything we're learning can only be applied to single term things. And what separates terms is addition and subtraction. So if I have addition and subtraction in my problem, I cannot use these rules. These rules are made for only single term problems. So how do I know a single term? There is no addition, there is no subtraction. So there's lots of ways to solve these. I am going to go through this in a very methodical step process, probably more steps than I need, but so you can see how this all kind of goes. So I am going to apply first, I want to get rid of all these parentheses, right? Anytime I solve any algebraic problem, I want to get rid of parentheses. And how do I get rid of parentheses? I distribute. So I use the distributive property. So I'm going to distribute this 3 to everything inside the parentheses. And then I'm going to distribute this negative 2 to everything inside the parentheses. So I'm just going to rewrite the 5y squared x cubed, and then 2 to the 3rd power, right? X to the 3rd power, y to the 3rd power. And the reason they all just got a 3 is because inside the parentheses there's nothing there, so there's a 1. So 3 times 1 is just 3. And then I'm going to be all over 4y x squared. And now I'm going to distribute the negative 2. So I get x to the negative 2, y to the negative 2. Now my parentheses are all gone, right? So what I can do now is apply the commutative property, which allows me to move everything around. And why I like to do this is it takes this and breaks it down to little smaller pieces so it's a little easier to see. So first I want to put all my numbers together. So I have a 5, and I'm timesing that by a 2 cubed, and I am dividing it by 4. So I put all my numbers together. Then I go through and I put my x's together. So I have an x cubed, right? That's this guy. I have another x cubed, right? That guy. All over a x squared, him, and then an x to the negative 2, him. So I make sure I got all my x's. Then I do the same thing for my y's. I have a y squared, a y cubed, all over a y, and a y to the negative 2. Now, do I have to do this step? No. Should I? Probably, until I'm comfortable with these. As you get more comfortable, can I do things a little bit faster? Of course you can, right? But to kind of get comfortable with them, I would recommend that we kind of go in steps. Because it was going to be frustrating too when you do the homework. is you take one of these problems that have a lot of variables in it and you go through the whole process, you get it wrong, and you have to do the whole thing again. So it's much better to do this slow and methodical, get it right the first time, because they can be kind of time consuming. Now I just do it in pieces, right? 2 to the third power is 2 times 2 times 2, which is 8. So 5 times 8 is 40, and then 40 divided by 4 is 10. So this whole thing just becomes a 10. Now, the reason I like to write it this way is I can now apply the rule. So what I like to do is just write a big X, and now I just start writing the powers. So I start here, I have a 3. I'm multiplying these two guys together, so that means I add, not add 2, add 3, that would help if I write the right number, add 3. Then going back to my red circle, I am dividing here to that guy, so division means to subtract, so I then subtract 2. And then finally, to get to this final guy, I subtract a -2. Do the same thing with my y. I got a y, start with a 2, going across, add 3. Going down, there's nothing there, but I know there is a 1. So I'm going to subtract the 1. And then he's also down, so then I subtract a -2. Now I just literally do the arithmetic, right? So I have x, 3 plus 3 is 6, minus 2 is 4, and then 2 negatives become a positive, so 4 plus 2 is 6, so that becomes an x to the 6th. Go to my y, 2 plus 3 is 5, minus 1 is 4, the 2 negatives make that a plus, so he also becomes a 6, and there is my final answer. Now, again, you don't have to do all of those steps or go into that much detail, right? If you wanted to flip the negatives around because that's what this property here says to do, then where is that? This guy, right? If you want to do that first, you can. If you want to do the cancellation method where you cancel out things that are the same, you can. I don't have a preference. I would say find what methodology works for you. But I like this one because it shows all the steps as well as how the formulas can help you simplify these. Because that's all you can do. You ain't actually solving this because it doesn't have an equal sign. All you are doing is simplifying this from where we originally started with this thing in the yellow box till we get down to this much neater thing in the green box. So 4.1 kind of goes, there's a lot of these problems to go through this. And just, again, take your time and do it in steps, and I think everything should work out pretty good because, again, all we have is 5 formulas. Same base, add the powers. Dividing, subtract the powers. Negative means flip it. Now be careful with the negative, right? Because I get some of this sometimes too, right? If I have 2 to the -3, that means flip it, so that becomes 1 over 2 cubed, which becomes 1 over 8. But if I have 1 over 2 to the -3, right? Well, that equals, I flip it, so that just becomes 2 cubed, which then equals a positive 8. So the way I like to think of it, whatever is in the bottom, move to the top, and whatever is in the top, move to the bottom. That's what the negative does. It does not make it negative. It just flips it. That's all it does. And anything to the 0 power is 1. So those are only kind of the weird ones that take a minute to wrap your head around. Any questions on exponents? Check my chat real quick. Make sure I didn't miss anything in chat. All right, guess we're doing all right. So let's talk a little bit about scientific notation. Right? And the reason scientific notation is covered here is because it is very similar to, it is an exponent. So a scientific notation, basically you have what we call a P, which is a constant. And then it always likes to use the time symbol. So I kind of try to make like a cursive-ish X to show that this is in scientific notation. And then it becomes 10. It's always to the base 10 to the K power, right? And what we have to be careful with is on your calculators, dang it, I did not want that to happen. Just like I lost everything. Ah, got too close to the top and I erased everything. Try again. Scientific notation. Written as P, a little funky X to show that's not times 10 to the K. Now, again, what I was trying to do without clicking on stop share, in your calculator, it can be written as something like this, X to the 10. But a lot of times your calculator will do either a single E or a double E. If you ever see that as your answer, that means your calculator put it into scientific notation. And the reason we use scientific notation is to take really huge numbers and make them a little easier to write out, or take really small numbers and make them easier to write out. So I'm not going to do these really big and really small because I don't want to move the decimal place a bunch of times. But say I have the number 5.632, and that is 10 to the 4th. And how you might see this in your calculator would be 5.632 EE4. Right, this is how, that's not a minus 4, that's just me getting sloppy with my writing. So these two are the same. This is typically how a calculator will write it, right? So to go from scientific notation to a number, this is a positive 4. So people always try to memorize this whole left-right thing. I find it confusing depending on what you're in. So what I like to think about it is if this is a positive exponent, then that means this number is big. So to make 5 bigger, I have to move the decimal that direction. And I am going to move the decimal that direction 4 places. So 5.632, I move it 4 places. 1, 2, 3. I've ran out of places, so I move it 1 more, and I put in a 0. So this is 56,320. Now, typically you won't see a number that small written in scientific notation, but I don't want to spend all the time just moving decimals 17 to 27 times, right? So if you can do 4, you can do as many as you would like. So that's how we do it. Now, if I have 5.632 times 10 to the negative 4, the negative tells me that's a small number. So now I am going to go, if 5's on the right of 0, so I need to go to the left, not left of 0, but closer to 0. So therefore, I'm going to move it to the left as a negative. So I rewrite this as 5.632, and I am going to go 4 to the left. 1, 2, 3, 4. Put a big decimal, and then fill in the waves with circles. So my answer is 0.0005632. Now, if I want to write a number that is not in scientific notation into scientific notation, right? So if I have 1, 0, 0, 4, 5, 6, 7, 9, 1, 3, right? And I want to put this in scientific notation. My decimal's right here, so I move it 1, 2, 3, 4, 5, 6, 7, 8, 9. I stop when there is only one number to the left, and that number has to be greater than 0. So I moved it 9 times. So I write 1 point. Now this is kind of pointless because the way I have this number, I'm not rounding it. So you still have to write out everything. And then times 10 to the 9. So typically you wouldn't do it with this problem, but what you would do is if those were all zeros, instead of writing all the zeros, you'd write it out. So that's where scientific notation is, now that we have technology, is not as a big a deal. But if you were in the sciences, a STEM major, chemistry, where you're doing labs and dealing with really big and really small numbers, a lot of times you write your answers in scientific notation. A calculator would probably write this in scientific notation and then round some of these numbers. So if I did this in a calculator, it would probably write 1.0046 times, well, if it was in a calculator, it wouldn't do the times thing, it would do EE to the 9. So again, that's what a calculator would do. So the key with scientific notation is really what I want you to take from this class is how to read it and understand when a calculator gives you this, that is in scientific notation, because you'll use this a lot in a lot of your other classes versus this one. But just to show how it relates to what we're learning here, if I went to solve a problem that was like this, 5.4, 10 to the 34 times 1.6, 10 to the negative 10 times 2.2 times 10 to the 16, right? If I don't know how to put scientific notation in my calculator, then I'm going to be like, all right, I don't even know how to solve this problem, right? Because if I can't put this in my calculator, how do I do this? And what I pray you do not do is don't write all these numbers out with all the zeros so that you can put it in a calculator. Use the rules from 4.1, right? Take my coefficients, my numbers on the outside, and rewrite them because of the commutative property. So I can do 5.4 times 1.6 times 2.2. Then remember, my base is this whole times 10 thing. I am multiplying, so I'm multiplying these, so I just add the powers. So 34 plus a negative 10 plus a 16. Now I can easily type 5.4, 1.6, and 2.2 in my calculator and multiply those, right? And I get 1.9008. And then I write my base. Actually, sorry, no, that's not what you should get. I got my decimal in the wrong place. You get 19.008 times 10. And then, so 34 minus 10 is 24 plus 16 is 40. And there's the answer. However, there is an issue. Remember, our decimal place is here. It needs to be 1 over because it has to be only one number in front of the decimal place. So I have to move it this way. And this is where I don't like the whole moving left and right, because a lot of times when students get this, they say, oh, I move to the left, I subtract. No, because I'm in scientific notation. So I like my way better. 19 is a bigger number. And since I'm going to make it look like a smaller number, I am then have to add 1 to move it to the right one. So the answer is 1.9008 times 10 to the 41. So now that you know this answer, if you want to use a calculator, you can practice seeing how to put in scientific notation in your calculator, which would be very beneficial before you take chemistry and a lot of these sciences, because they give you a lot of worksheets on making sure you know how to properly type in scientific notation. Any questions on scientific notation before we go on to the next section? All right. So 4.2 is polynomials, right? So, and it's added and subtracted polynomials. And all it means to be a polynomial, right, is I have I could have a coefficient, which the book calls k. Then I have my variable x, and I have it to some exponent. And so this is called a monomial. Hopefully I'm saying that right, because it is one term. And what makes something a polynomial is this guy, the n, the exponent, right? The exponent has to be a whole number. So that takes you all the way back to our first week of what is a whole number. Whole numbers are 0, 1, 2, 3, 4. So our exponent has to be a whole number. Can it be something else? Yes. But if it is something else, then it is not a polynomial. That's the key. Now, we're only going to work with polynomials, so that's a good thing. But if you take 122 next, college algebra, the key is understanding n does not have to be a whole number. It can be other things. It just makes other types of mathematics. But for something to be a polynomial, the exponent must be a whole number. And k can be anything. It can be, as long as it is a real number. It can be negative, it can be positive, it can be a fraction, it can be everything. So some examples here, right? 9x squared is a polynomial, and it is a monomial. And then I could have 7x minus 23. That one we call a binomial. Right? Because it has two terms. Or we can do negative y to the fourth plus 6x minus 7xy. And that is a trinomial. Oops. Because it has three terms. So I want to stop there, right? But they keep going. So this kind of what we got to understand what polynomials are, right? And the big takeaway is this. The exponent has to be a whole number. So when you have something, say I have negative 3x plus 7x squared minus 22x to the fifth, right? Is this a polynomial, right? And the answer is yes, right? Because he has a 1 on him. So he's positive, he's positive, he's positive, so that is a polynomial. Now, it might ask you something to what is its degree? And the degree is the highest exponent. Right? It's not the one that comes first, even though that's typically how we write our problems. I purposely wrote this one out of order so we could see that the degree for this problem is 5. That is the largest exponent. And then it might ask you, what is the leading coefficient? And leading typically means first, but because this thing's not written in the right order, the leading coefficient goes with the highest degree. So that means the answer is negative 22. So there's a lot of kind of like the definitions and the theory behind polynomials. So in this section, 4.2 is how to add and subtract. So we have let's go black here. 3x squared minus 2x plus 5 plus 2x squared minus x plus 3. Right? Again, my exponents are all positive, so therefore these are two polynomials, and we're adding them together. So to add polynomials, there has to be two things to happen, right? And I like to think of them as two rules. You must have the same variable and the same exponent, right? Or if you want to think of it in other ways, same letter, same power. You can only combine things that meet both those rules. So 3x squared and a negative 2x cannot be combined because even though they are the same letter, they are not the same power. 2 does not equal the 1 that's on him. So therefore, I cannot combine them. Don't confuse that to multiplication and division. When things are single terms, we don't care about these. So the way I think about it, anytime you hear the word combine like terms, in your mind now, that should remind you that you are adding or subtracting, because that is what separates terms, addition and subtraction. Multiplication and division means it is one term, and then we use the rules that we covered at the beginning of the hour, right? So combining like terms means that we add and subtract. So clean this up a little bit. We can actually finish this problem. Because I'm adding here, I can apply the associative property and just get rid of the parentheses. So I can just have 3x squared minus 2x plus 5 plus 2x squared minus x plus 3. And then I could use the commutative property and put like terms together. So 3x squared plus 2x squared. I put both of the ones that had x squareds together. And you don't have to. You could just circle them if you want, and that way you know to do it. But I'm going to move things around for now. Then I have a minus 2x minus an x. All right, so there's those two terms that have the same power and same letter. And then finally, I can add my numbers, plus 5, plus 3. Now I have my like terms next to each other. And when I add these, the variable and exponent do not change. So 3x squared plus 2x squared equals 5x squared. A lot of times when I see people get these wrongs, they'll give me the answer 5x to the 4th. No, the exponents can only change if you're multiplying and dividing, which means a single term. If I'm combining terms, I only can change the numbers in the front, the coefficients. So 3x squared plus 2x squared becomes 5x squared. Oops, fix this, that's supposed to be a negative x. Negative 2x minus x, and there's really a 1 here. So negative 2 minus 1 is a negative 3x. And then 5 plus 3 is 8. And that is the final answer. If we have, we'll do one more here. 5x squared minus 9x minus an 11. Put that in parentheses just for now. And then minus an x squared minus 3x plus 1. Now, I can't just drop these properties now. I mean, parentheses, sorry, the associative property, because I am now subtracting, right? So I can't apply the associative property. But I remind myself there is a negative 1 there. So what I do is I distribute the negative 1 through to get rid of the parentheses. So this becomes 5x squared minus 9x minus 11. Negative 1 times negative x squared is negative x squared. Negative 1 times negative 3x is a positive 3x. And negative 1 times a positive 1 is a negative 1. I can now move my things around so that my like terms are next to each other. So 5x squared minus x squared minus 9x plus 3x minus an 11 and minus a 1. Remind myself there is a 1 there. So 5x squared minus 1x squared is 4x squared. Negative 9x plus 3x is a negative 6x. And then a negative 11 minus 1 is a negative 12. And I then have my addition and subtraction. So just to recap 4.2 real quick, right? Combining like terms must have the same variable and same exponent. When I'm multiplying them, right, which is 4.3, multiply terms. Oops, that's an ugly R now. Hope if I use an eraser. Terms, right? Some of you might remember the whole FOIL thing, right? I have x plus 3 times x plus 2, right? I have a times here because the two parentheses are touching, so I'm not combining terms. I basically am distributing the first thing through everything, and then I'm distributing the second thing through everything. So we'll talk FOIL in a minute, right? But if you have don't like FOIL and you have a hard time seeing this, you can rewrite this by taking the first term, x, and putting it on the outside of x plus 2, and then taking your other guy, the plus 3, and putting that in x plus 2, and then distribute. So that becomes x squared plus 2x, distribute, plus 3x plus 6. And notice the two terms in the middle are the same. This happens a lot. This is why we had to learn add and subtract before we can multiply. So this just becomes x squared plus 5x plus 6. Now for you all, although I wonder what FOIL was, in case you don't remember it, FOIL means first, outer, inner, last. And basically, let me clean up my arrows in the first thing, and I'll show you FOIL by colors to show you that we just basically did FOIL by what we did. So first, we'll do a black arrow, right? X times x, and there is our x cubed. Then outer means I take the two outer ones and I multiply them, and I do that in blue. Well, x times 2 is the 2x, so there he is. Then my inner, I'll do a green arrow. That would be the 3 times the inner term, 3x. So there is my 3x. And then finally, our last, and our red arrow is multiply the last two things together, and there is our 6. So FOIL just lets you skip this step of rewriting it. But that is what you're doing when you FOIL. You're making sure you distribute through everything through. And then a lot of times, like I said, the two middle terms will probably be able to be combined because they have the same same variable, same exponent. Yeah, we'll do a quick division one, just so we can get basically a nice video made for all of these, and we can talk more of this next week if we need to. Division is a little more complicated, right? This is 4, 4. So when we're dividing, 4ax squared minus 6a squared x over 2ax. So now we're dividing. What I would do is break these apart. 4ax squared over 2ax minus 6a squared x all over 2ax. And now I have two individual terms, and now I just do the rules of 4.1, right? 4 divided by 2 is 2. A over a is, they both have those ones. 1 minus 1 is 0. Anything to the 0 power is just 1. So I'll just put that there to see where it went. He has a 1 on him. X squared over x is 2 minus 1 is just x. So that just becomes a 2x. Oops, not equal, sorry. Bring down my subtraction sign. 6 divided by 2 is 3. A squared over a1 is a. X divided by x is just 1. So that comes a 3a. So the final answer is 2x minus 3a. So as I was saying, the rules from 4.1 are really important because we're applying those when we're moving all these things around. So if you get comfortable with 4.1, 4.2, 4.3, and 4.4 are just moving terms around by either add, subtract, multiply, or divide. Each operation gets its own section. That's why it seems like I might be going a little fast, but I want to put this all in one video so you can kind of refresh as you kind of go through some of those assignments and when you look over my notes on OneNote. What becomes more challenging is this trick only works if this is a single term. All right. And I think this is where the video is going to come to be in handy for you, is when things are not a single term. So say I have, and this will be the last problem we do today, ax cubed plus 4x squared plus 3 all over 4x squared minus 1. And this is right out of your book. All right, so I like to do this problem right out of the book so that you can go back and review. I've already done this problem in a previous video on my YouTube page, but it kind of fits in here as well, so I'm going to do it with this section as well. So I can't, breaking this apart is not going to help me any like I did in the previous problem. So the only way to solve this problem is to do long division. So 4x squared minus 1 long division into 8x cubed plus 4x squared plus 3. So if we did this in class, I always write on my board scrap paper. Right? Because we want to give everybody a laugh with some problem they don't want to do anyway. But off to the side, I kind of do these steps and on what I call my scrap paper. So what you do is you take the first term of the numerator and you divide it by the first term of the denominator. So 8x cubed all over 4x squared. 8 divided by 4 is 2. X cubed divided by x squared, same base. Subtract the powers. 3 minus 2 is 1. So that becomes 2x. Right? So there's step 1. Step 2, I take the 2x from the answer from step 1, and I multiply it by my denominator, 4x squared minus 1. So that gives me 8x cubed minus 2x. So, be careful because I always forget to do this part. The answer to step 1 gets written right above the thing you divided it by. And then I take the answer to step 2 and I write it where it goes. So he has an 8x cubed. He has an x squared. He has a 3. So there is no 2x. And if there was, he would kind of fall in the middle here. So I'm going to kind of put him over and I'm going to erase this guy and just give myself a little room. Put a plus 3 over here. If you want, you can put a plus 0x here just for placeholder purposes. And then what you have to do is you have to subtract these. So what I do is I put it all in parentheses to remind me that I'm subtracting through the entire process. A lot of times when I see students do this, they do really good and remember to subtract the first term. Then they forget to keep subtracting and they start adding. So 8x cubed minus 8x cubed is 0. That always has to happen. And the whole point of this little scrap paper piece is to guarantee that always does happen. If it doesn't happen, that means you made a mistake somewhere. So those canceled. I have 4x squared minus nothing below it, so I just bring him down. 0x minus a minus 2x becomes a positive 2x because this negative and this negative become positive. And then I bring my 3 down. Now, I do the whole process again. So I take the first term again, and I divide him by the denominator. So I take 4x squared divided by 4x squared, which equals 1. I then do 1 times the denominator and get 4x squared minus 1. Again, don't forget to write up here what you divided it by, so he goes there. And then I write him down here of 4x squared with a minus 1 under the 3. Put in my parentheses because I am subtracting all the way through. 4x squared minus 4x squared is 0. 2x minus nothing is I just bring down a positive 2x. Positive 3 minus a negative 1 means add, so that becomes a plus 4. And I ran out of room, but I do it again. 2x divided by 4x squared equals 1 over 2x. That is not an integer, so I stop, which means I am done. So you keep going until you do not get an integer, and 1/2 is not an integer, is a rational number, so I have to stop. So my final answer is I take everything I have up top, which is called my quotient, Q. So this is 2x plus 1. This piece that is left down here is called my remainder. So I then plus my remainder of 2x plus 4 all over my denominator, D. So 4x squared minus 1. So if you're doing Hawks, it asks for the answer to be Q plus R over D. That's what it's talking about. Quotient, which is what is on the top, my remainder is what is left over my denominator. And sometimes you'll do a problem that you don't get a remainder, and that's okay. All right. But if you do, this is how you do it. So you have this video because this is probably the hardest one of the hardest homeworks in chapter 4 because it's very tedious and a lot of students just either skip it or email me after so many attempts. So this video should help do this. So we covered a lot in this hour. 4.1 was our 6 rules of exponents. 4.2 was adding and subtracting polynomials. 4.3 was multiplying polynomials. And 4.4, dividing of polynomials. So the lecture actually puts us a little ahead for next week, but that gives you time to kind of catch up if you want to. So any questions on anything we've covered so far? All right, I'm going to share this link as well as post this video on the YouTube channel.